Learning target 4, solve a system of equations using elimination. So we've learned two ways to solve an equation so far already. We've learned by graphing, where you graphed the two lines and then found where they intersect, and that's the solution. We've also done by substitution, to where if you have something like that, you can substitute it into the other equation just right there. Okay, those are the two things we've done already. Now we're going to do elimination. The elimination method is very, very useful in some cases, and it'll save you a lot of work in a lot of cases, especially if you don't have one variable already isolated and can't use substitution right away. The goal of the elimination method is, so you've got your two equations. Your goal is to eliminate one of the variables. So once you're done eliminating, your equations will no longer have one of the variables in it. So I'll kind of talk you through the steps on how to actually eliminate one of those variables, and once you've done that, how can you find the solution to the system. Okay, so here are some examples. The way that you need to eliminate this, so remember our goal, eliminate one of the variables. And the way that we're going to do this is we want them to, first of all, line up like this. So you see you've got your x's lined up over top of each other, and your y's lined up over top of each other, equals, and then some constant number over here. That's the first thing, is we want these to line up like this. The second thing that we need to do is we need to have one of our variables be the opposite in the other equation. And let me explain what that means. So here you see we have a 7y, positive 7y. Okay? It's lined right on top of negative 7y. Okay? So in this step, it's already done for us. So we first need to look for something like that. If it's not there, we need to make it happen, and we'll talk about how to do that. But in this case, it's done for us. So we've got in one equation a positive 7y, and in the other equation a negative 7y. Once we've got those two things, all we do is add the two equations together. So it's one big addition problem, and you add this first equation with the second equation, and you'll see that these y variables will drop out. They'll eliminate, and that's our goal. It's to eliminate one of the variables. Okay. So first, let's go ahead and add these together. We've got an x plus another x, which gives us 2x. We've got a 7y plus a negative 7y. 7y plus negative 7y cancels out. Okay. All of that drops out. They cancel each other out, and so you have no more y's. All the y's are eliminated, in other words, and that was our goal. So we're left with a 2x, no more y's, and then on the right side of the equations we have 13 plus 5, which is 18. Okay. With the y's all out of the way now, we can just solve this for x. We already know that x equals 9. So now, very similar to what we were doing with substitution, you take that x and you just substitute it into one of these equations above. So I'm going to just substitute it into that first one. 9 plus 7y equals 13. Subtract a 9 from both sides, and y equals 4/7 if we divide them both by 7. Okay, so we would have a y coordinate of 4/7. Okay, so that's how you can use the elimination method, and it works very, very quickly, especially if you have something like this where it's already set up for you. Those y's just cancel each other out right away, and you can easily solve for x, substitute back in, and solve for y. Okay. Here's an example. If we look at the second one, here's an example where we don't necessarily have the same number of each variable. Okay, so like here we have 2p, but then down here we have 5p. There's 3q and a negative 1q. So we're going to need to do something to this equation to make one of the equations have something like this where we can easily cancel. It doesn't look like we can do this with the p's very easily, because what you're going to want to do is multiply one of the equations by something that'll give me the same number of variables in the other equation. So like I can't really fast just multiply this whole equation by something and magically make a negative 5p appear right there. Okay, so I'm going to look at the q's. Okay, I can multiply, remember I want to multiply this whole equation by something so that I get a negative 3q, because a negative 3q will cancel out this positive 3q. So what I'm going to need to do is multiply this whole equation, both sides, by 3. If I do that, I will get 15p minus 3q equals 33. So this equation has now just become this. And I'm going to copy down that first one. And now you see, just like in this first example, we had a positive 7y and a negative 7y. You can see over here now we've got a negative 3q and a positive 3q. All right, so those will be able to cancel each other out very nicely. So we'll go ahead and add the first equation with the second equation. Again, our q's drop out because a negative 3q plus 3q is just 0 q's. So we've eliminated that variable, but we still have some p variables over here. So a 15p plus 2p is 17p equals 33 plus 18 is 51. Okay. Now I can just go ahead and solve this for p. So you get p equals 3. Now we need to find what q equals. So we can take this p equals 3 and substitute it back into one of these equations. So I'll substitute back into the first one. 2 times 3 plus 3q equals 18. So I've got a 6 over here. Subtract 6 from both sides and I'll get 3q equals 12. And divide them both by 3. And q equals 4. So we've got p equals 3, q equals 4. All right. Sometimes you'll get an equation that neither variable looks very easy to eliminate. Okay. For instance, in this one, I can't really multiply 2 by anything nice to get it to negative 7 to cancel out the positive 7. Similarly, I can't really multiply just one of these equations by something to get it to this positive 4 to be like a positive 3. So I'm going to actually have to multiply both of these equations. Okay. The way that I can do this, I can choose to do either the y's or the x's. I think I'm going to choose the y's. So I'm going to multiply this top equation by 3. Looking ahead a little bit, that'll give me 12 y's. Okay, so I want to make this bottom one have a negative 12y. And so I know I've got a negative 3y. Negative 3 times 4 would give me a negative 12y. So if I multiply both of those out, I'll get 6x plus 12y. And then common mistake here is to kind of forget to multiply the right side by 3 as well. But you have to do that by the golden rule of algebra. Okay? So you have to multiply this 3 by 40, and that'll give you 120. On this bottom part, 4 times a 7x gives us a 28x. 4 times negative 3y is minus 12y. And then 4 times 4 finally gives us 16 over on that right side. So we've got to a point where it's nice and easy. These y's we see will cancel. Let's add these two equations together. All right. So that leaves us with 6x plus 28x, which is 34x. Positive 12y and negative 12y cancel each other out. Those just drop out. And that's our goal, to eliminate one variable. 120 plus 16 equals 136. Okay, so we've got 34x equals 136. We've accomplished our goal of eliminating that y variable. And now we just need to figure out what x equals. So x equals 4. Okay, so we know what the x is. Now we need to figure out what y is. I'm going to use one of these original equations. So I'm going to take that 2x plus 4y equals 40. And I'm going to substitute in the 4. So 2 times 4 plus 4y equals 40. So 8 plus 4y equals 40. And y equals 8. So our solution for this would then be 4, 8. Okay? Now, again, there are some special cases. So we saw these with substitution. We saw it with graphing. Now we need to look at some special cases for when we're eliminating. The first one, if you look at these two equations, you can see there's a 5x here and a negative 10x here. And when I see that, I think that it's going to be very easy to cancel these x's, because all you would have to do is multiply this first equation by 2 rather. So if we multiply that by 2, what we'll end up with is a positive 10x. And if you look at this negative 10x, that's a good thing that we have this positive 10x. We'll also have a plus 6y equals 2 times 10 is 20. All right. The next step is we need to add these two equations together, okay, our original and the new one that we just created. So negative 10x plus a 10x, that leaves 0 x's left. And then negative 6y plus a 6y, well, that leaves 0 y's left. So there are no x's and no y's, so that just means we have 0 over here on the left. And we have negative 12 plus 20 is 8. Okay, so we actually eliminated both variables and got 0 equals 8. Okay, well, we all know that 0 does not equal 8. So that means that, as we've seen before, there are no solutions. And if you think back to substitution, it looked very similar to this. And if you think back to graphing, that's where we had two parallel lines that never ever crossed each other. If we look at this next special case, I see that there are negative 3x in the top equation and a positive 6x in the bottom. So I'm going to take that first equation, multiply the whole thing by 2. Okay, that gives me a 2 times negative 3x, which is a negative 6x. And that looks like a good thing at the beginning, because we've got a positive 6x and a negative 6x, and those will cancel each other out. But then we've got this 2 times a 4y, which is plus 8y, and equals negative 14. So we'll go ahead and add those together. Okay, so we've got 0 equals 0, and that is true. 0 does equal 0. So as we've seen in the past, if you have something like this, that means that there are infinite solutions. That means these two equations are in fact the same line or the same equation, just written slightly differently. But if you were to graph those, you would see that they both make the same exact line. Your before class is to solve this system using elimination.